Hello, my name is Bojan Mitov, the president of Mitov Software, and in this video I will show you how you can create SCADA Modbus Industrial Control applications and PLC devices with ControlLab and Visuino Pro. Modbus is a serial communication protocol originally developed by Moricon. It is widely used in the automation industry to communicate with PLC controllers. Modbus can communicate over serial communication RTU or ASCII format or over TCP/IP Ethernet. In Modbus, there are two types of devices: master devices or clients and slave devices or servers. Master devices are usually user interface or control applications, and slave devices are typically endpoint PLC controllers. Slave devices are accessed by unique IDs. Each device consists of tables. There are four types of tables: digital inputs, coils, input registers, and holding registers. The digital inputs and coils are simply on-off endpoints. The basic register is 16-bit, but multiple registers can be combined into bigger logical registers. Each digital input, coil, or register has unique ID within its table. Modbus uses operations to access the devices. Those operations can be read, single coil, digital input, holding or input register, write, single coil, digital input, holding or input register. There are also operations to read or write multiple of those. There are three typical Modbus tasks: implementing Modbus devices, implementing Modbus clients, or implementing bridges that bridge between TCP/IP or variety of serial communications. With the increased popularity of the Arduino controllers, a number of companies have started developing and using Arduino-based PLC controllers. To make it easy to program those controllers, Mitov Software introduced Visuino Pro. Visuino Pro is graphical development environment for Arduino. It automatically generates Arduino code and programs the boards. It has built-in data visualization. It maps directly the software and the hardware components, making it easy to write software to control the hardware components. It provides uniform communication over serial or socket-based channels. It includes serial port socket communication and MQTT components compatible with CommunicationLab for Delphi and C++ Builder. The Pro version of Visuino also includes Modbus components that can be used to program PLC controllers. Here is how Visuino and Visuino Pro work. You use Visuino to develop your project, dropping components and connecting them with wires. Once when you have finished your design, you click on a button and Visuino will generate C++ code and open the Arduino IDE. From the Arduino IDE, you can upload the code to a variety of devices, including industrial controllers like this Controllino shown on the picture. Visuino Pro is currently in fully functional beta. Links are posted regularly in the G+ Visuino Visual Arduino Developers community and also in the Facebook Visuino Visual Arduino Developers group. You can download it by joining the G+ community or the Facebook group. We will take a quick look at Visuino Pro. This is the design area where we can drop components. The components are available in this palette here, and they are organized in categories and subcategories. Each component can appear in one or more categories. On the left, we have the navigation area, and underneath we have Object Inspector, where we can edit the properties. On the bottom, we have serial terminal and scope, and when we use packet communication, we can have also instrumentation panel. In Visuino Pro, we also have code view, where we can see the code that will be sent to the Arduino IDE for compilation. The code will automatically change as we change the properties. Or drop components. For this presentation, I will use two Controllino components manufactured by Controllino. Controllinos are Arduino-based industrial control PLCs. They come in many flavors, but typically include RTC, RS485, and Ethernet capabilities, making them perfect for Modbus applications. They are fully supported by Visuino and Visuino Pro. Now we will implement Modbus Client. I will use Controllino Maxi for it. Double-click on the Arduino, select Maxi as board. I will use the standard Maxi. Maxi has multiple serial channels. In the component toolbar, we will search for Modbus. We will select Modbus Server or Slave Serial Protocol and drop it in the design area. We will connect the output of serial channel 0 to the input of our Modbus protocol, and the output of the protocol to the input of the serial channel. Next, we need to implement a Modbus device. I will drop a Modbus device component and click on this button to open the tables editor. I will add one calls table and one input registers table. I will select the calls and add one call. Select the input registers and add two floating point input registers. Our device is ready, and now I can connect it to the Modbus protocol. I will connect the output pin of call 1 to one of the digital pins on the Controllino. In this case, digital pin 2. To read analog data, I will use the popular DHT11 temperature and humidity sensor. I will connect the sensor pin to the pin where I have connected my sensor on the Controllino. I have decided to use digital pin 0. And I'll connect the temperature and the humidity to the two input registers. We have a ready Modbus PLC controller. Now we can click on this button to generate the Arduino code and open the Arduino IDE. Make sure that Controllino Maxi is selected as device and that the appropriate COM port is selected to upload into the device. Click on this button to compile and upload the code. The code is uploaded. Now we will test the device. To connect to our device from Delphi, we will use ControlLab. ControlLab is a Delphi and C++ component library for industrial automation. It contains serial and socket communication components, includes Modbus and OPC components, as well as PID and relay controller components. ControlLab is currently available as fully functional beta. You can download it from my blog post where I regularly post updated versions. Soon the library will be available on the meetup.com website. In Delphi, I started and saved new VCL application. To access remote device, we can use the Modbus Remote Device Access component. In the component, we can specify the device ID where we want to connect. And we can add operations. We can issue variety of requests. To access our test device, I will add two read input register in 32-bit float format. To control the coil, I will add a write coil request. To display the data from the DHT11, I will add a thermometer and gauge. To control the coil, I will use a checkbox. To be able to connect the checkbox with OpenWire connections, I can add Boolean source pin to the checked property of the checkbox. I'll switch to the OpenWire view, connect the checkbox to the input pin of the write coil request, the output pin of the first read input register request to the thermometer, and the output of the second one to the input of the angular gauge. Before I add protocol to connect to the device, I will show you one great feature of ControlLab. You can simulate your device and test your device access without using any communication right inside your Delphi application. Switch to the form designer, search for Modbus, and add a Modbus device. Double-click on the device to add tables. In the tables, add the elements you want. The same way as we did in Visuino. In the OpenWire view, we can connect the Modbus Remote Device Access component to our Modbus device directly without using any other protocols. To test the device, I will add a couple of components to display the coil and generate some value for the registers. I will use LED for the coil and a signal generator to generate some values for the input registers. I will make sure the values are between 0 and 100. In the OpenWire view, connect the signal generator to the two input registers and the LED to the coil. If we try our application will notice that it is not reading data. The reason is that Modbus is a slave protocol. You have to issue requests from your client to retrieve the data from the server or slave device. Write requests are automatically handled when we click on the checkbox. However, to read the data, we need some form of clocking. We can use a button, or I can use a clock generator. I will set a rate of 1 or once a second. I will connect the clock generator to the clock pins of the two read input register requests. Now we can run the application. You can see that we can read and control the Modbus device. Using this trick, we can debug both Modbus devices and remote access to other controllers. Now we can remove our debug device and connect to our Controllino. The Controllino is connected to a serial port. For this, we will need a COM port and a Modbus serial communication protocol. We need client serial protocol. Double-click on the COM port to select the COM port where our device is connected. Switch to the OpenWire view. Connect the Modbus to the Modbus protocol, the output of the protocol to the input of the COM port, and the output of the COM port to the input of the protocol. Compile and run the application. You can see the temperature and the humidity in the room. You can see the DHT11 sensor connected to the Controllino on the appropriate pin D0. And now pay attention to pin D2. And if I click on the checkbox, you will see that I can control the D2 pin on the controller. The LED will turn on and off. Now we will implement bridging using another Controllino. I will do the bridging through the serial RS485 protocol between the two Controllinos. I will add another Modbus server serial protocol and quickly connect it to the RS485. And I will connect our device to this protocol. Now we can talk to our device through both serials. And I will upload to our device. I already showed you how to do that. Now I will use Controllino Mega to implement Modbus Bridge. Mega has Ethernet controller and we need to configure it. Set MAC address. You can use MAC address generator to generate it. Set fixed IP port available on your subnet. Enable the fixed IP port and disable DHCP. To make the connection, we need to add server socket. The default Modbus TCP port is 502. Now we can add the Modbus protocols. We need master serial protocol to connect to the other Controllino, and we will connect it to the RS485. We will make the Controllino a safe device on the internet. For this, we will add a TCP slave protocol. Connect the socket to the protocol and finally connect the two protocols together. We are ready. We have Modbus bridge implemented in Visuino Pro. Now we can click on this button to generate the Arduino code and open the Arduino IDE. Make sure we have selected Controllino Mega and the appropriate COM port where the Mega is connected. Click on this button to compile and upload the code. The code is uploaded. Now we can change the Delphi application to connect to the Mega bridge and then through that bridge to the Maxi Controllino. We will remove the COM port and the serial protocol. To connect over TCP, we will add a client socket. We will set the TCP IP address of the device. We can copy it from Visuino. And set the port to 502. Search for Modbus Client. Select TCP protocol and add it. Connect the output of the protocol to the input of the socket and the output of the socket to the input of the protocol. Connect the Modbus pin of the remote device access to the Modbus pin of the protocol. Compile and run the application. You can see that we still receive the data. The data is sent from the sensor to the Maxi and through the RS485 to the Mega, and from the Mega through the TCP/IP Ethernet to our Delphi application. And I can control with the checkbox the LED on and off. In addition to Visuino and Delphi with ControlLab, you can also use OpenWire Studio to implement and access Modbus devices or bridge between protocols. I will quickly show you how we can connect to our Controllino Maxi through the Mega bridge and display the values and control it. I will start with new OpenWire Studio project, add client socket, set the IP address and the port, add Modbus Client or Master TCP/IP protocol, connect the socket to the protocol, search for remote, and add Modbus Remote Device Access component. Connect the component to the protocol. Add two 32-bit floating point input register requests and one write coil. Add a checkbox to write into the coil. Add thermometer and gauge. Connect the thermometer and the gauge to the Modbus Remote Device Access component. Add clock component to issue the read requests. Set the rate to 1. Connect the output of the component to the two clock inputs of the Modbus Remote Device Access component. Run the application. You will see the data arriving, and we can control the digital pin on the Controllino with the checkbox. We can use all the three platforms, Visuino, Delphi and OpenWire Studio, exactly the same way, implementing in each of them Modbus clients, Modbus servers, and bridges. OpenWire Studio is currently available as a fully functional beta on the openwirestudio.com website. My name again is Bojan Mitov, the president of Mitov Software. Mitov Software offers variety of Delphi and C++ builder products, including VideoLab, a video processing library, AudioLab, audio processing library, SignalLab, a digital signal processing library, VisionLab, computer vision library, PlotLab, data visualization library, InstrumentLab, a visual instrumentation library, Intelligence Lab, artificial intelligence library, Logic Lab, Boolean logic library, Animation Lab, Universal Animation Library, Communication Lab, Serial and TCP/IP Communication Library, that also includes MQTT, ControlLab, Industrial Control Library, Visual Live Binding, Universal Visual Live Binding Library, the free Mitov Runtime Delphi library. In addition to the libraries, Mitov Software also provides OpenWire Studio, a graphical development environment for Windows, Visuino, a graphical development environment for Arduino type boards and microcontrollers, Visuino Pro, a graphical development environment for Arduino-based industrial PLC controllers. Mitov Software also maintains some open source Delphi libraries, including the OpenWire library and iGDI Plus, a Delphi-friendly GDI Plus library. The majority of the components included in the libraries are already ported to support cross-platform development in Windows, Mac, Linux, iOS, and Android. Mitov Software is working actively to port practically all of the components to cross-platform development. This concludes this session. Thank you for listening, and now it's time for questions and answers.